Welcome. Today we're diving into the Command Query Responsibility Segregation, or CQRS pattern. This architectural approach is gaining traction for its ability to separate read and write operations in modern applications. By splitting these responsibilities, CQRS allows each side to be optimized independently, leading to improved performance, scalability, and security. In this video, we'll explore what CQRS is, why it matters, and how it can transform your application architecture, especially when working with cloud platforms like Azure. Let's start by understanding the core problem CQRS aims to solve. Traditional application architectures, a single data model is often used for both reading and writing data. While this CRUD approach is straightforward and works well for simple scenarios, it can quickly become a bottleneck as your application grows. Read and write operations typically have different performance and scaling needs. Using one model for both can lead to data mismatches, lock contention, performance issues, and even security challenges. As a result, the model becomes overly complicated and harder to maintain. Let's see how CQRS addresses these pain points. CQRS stands for Command Query Responsibility Segregation. It's a design pattern that separates the write operations, known as commands, from the read operations or queries. Commands are responsible for updating data, while queries simply retrieve data. This clear separation allows each side to be optimized for its specific purpose. For example, commands can focus on business logic and validation, while queries can be tailored for fast, efficient data retrieval. This approach not only simplifies your system's design, but also enhances scalability and performance. Commands in CQRS are more than just data updates, they represent specific business tasks. For instance, instead of a generic update like set reservation status to reserved, a command would be book hotel room. This approach captures the user's intent and aligns with business processes. To ensure commands succeed, it's important to refine both the user interaction flow and the server-side logic. Sometimes, commands are processed asynchronously, allowing the system to handle tasks in the background and improve user experience. Make commands robust. Validation is crucial. On the client side, you can prevent obvious failures by checking conditions before sending a command. For example, if no rooms are available, the book button can be disabled, providing immediate feedback to users. On the server side, business logic should handle edge cases gracefully, such as managing race conditions when multiple users try to book the last available room. Asynchronous processing, like queuing commands, can further enhance reliability and responsiveness. Queries in CQRS are designed to retrieve data without altering it. They return data transfer objects (DTOs) that present information in a format optimized for the user interface or reporting needs. By keeping queries free of domain logic, the system becomes easier to maintain and more efficient at serving data. This separation ensures that read operations are fast and tailored to the needs of the application, without the overhead of unnecessary business logic. One of the key principles of CQRS is maintaining separate models for reading and writing data. The write model is optimized for handling commands, ensuring data consistency and enforcing business rules. The read model, on the other hand, is tailored for efficient data retrieval, often using projections or DTOs. This separation improves clarity and performance but requires custom logic, as automatic code generation tools may not support CQRS out of the box. Its most basic, CQRS can be implemented with both read and write models sharing a single underlying database. Each model maintains its own logic, but they operate on the same data store. This approach improves clarity and performance by separating concerns while still relying on a shared infrastructure. The write model handles commands and validation, while the read model focuses on generating fast, presentation-ready data. More advanced scenarios, CQRS can use completely separate data stores for reads and writes. This allows each side to scale independently and even use different storage technologies. For example, you might use a relational database for writes and a document database for reads. However, this setup requires careful synchronization to keep both data stores consistent, often using event-driven mechanisms to update the read store when changes occur in the write store. CQRS brings several advantages to modern application design. It enables independent scaling of read and write operations, allowing you to optimize each for its workload. Read and write models can use schemas tailored to their specific needs, improving performance and security. By separating concerns, your codebase becomes cleaner and easier to maintain. Additionally, storing materialized views in the read database can simplify queries and boost responsiveness. Despite its benefits, CQRS introduces complexity. When combined with patterns like event sourcing, the design can become even more intricate. Messaging systems are often used to process commands and publish events, which brings challenges like message failures and retries. Separating read and write databases can also lead to eventual consistency, where the read side may lag behind the latest updates. Careful planning is needed to handle these scenarios and ensure a robust implementation. CQRS is especially useful in collaborative environments where multiple users interact with the same data, or in applications with complex task-based user interfaces. It shines when you need to fine-tune performance for reads and writes separately, or when different teams are responsible for different parts of the system. CQRS also supports evolving systems that require frequent changes to business rules or integration with other subsystems. However, for simple domains or CRUD-style applications, it may be overkill. CQRS pattern aligns well with the performance efficiency pillar of the Azure well-architected framework. By separating read and write operations, you can optimize each for its specific workload. This is particularly valuable in high read-to-write scenarios, where the read model can be scaled horizontally to handle large query volumes, while the write model remains lean to minimize conflicts and maintain consistency. Some advanced CQRS implementations incorporate the event sourcing pattern. Here, the system state is stored as a chronological series of events. The event store acts as the write model, while the read model generates materialized views from these events. This setup allows for efficient queries, easy regeneration of views, and a complete audit trail of all changes. However, it also increases complexity and requires careful handling of consistency and performance. Let's look at a practical example. In a CQRS implementation, the read model might define interfaces for retrieving product data, such as finding products by ID or name or listing out-of-stock items. The write model, meanwhile, handles commands like adding new products or rating a product. Command handlers process these requests, ensuring business logic is applied and data is updated correctly. This separation allows each model to evolve independently and be fine-tuned for its specific responsibilities. Implement CQRS successfully. Consider best practices like data partitioning to improve scalability and reduce contention. Related patterns, such as event sourcing and materialized views, can further enhance your system's performance and flexibility. By combining these approaches, you can build robust, scalable, and maintainable applications that are ready for the demands of modern cloud environments.